In this video, we're going to cover how to simplify square roots. And square roots we're going to look at are going to have variable expressions, so things like the square root of x to the fourth. But before we do that, just a quick review of square roots. We know our square root has a radical symbol, and the value under the radical symbol is known as the radicand. So if we're taking the square root of 4 is our radicand. Then we take the square root, we're basically asking what number times itself is that radicand, or is 4? And we know that 2 times 2 is 4, negative 2 times negative 2 is also 4, so our answer to this is going to be positive and negative 2. And there are two ways our square roots can be written, either with no value here or with the value of 2 here, indicating we're looking for the square root, so we're looking for what number multiplied by itself twice is that radicand. So how do we use that to simplify expressions like this, the square root of x to the fourth? Well, we know our value here is 2, and we can rewrite any square root as an exponent. So the square root of any value, the square root of x to the fourth, is going to be equal to, since our value here is 2, we can raise this to the 1/2 power. So we're basically just taking our value 2 here and raising it to the 1/2 power. Now we know from our power to a power property, if we have an exponent raised to a power, so we have x to the fourth raised to the 1/2 power, we're going to multiply these. So we want 4 times 1/2. So this is going to be x to the 4 over 2, which is just x to the second. So what's a shortcut we can use? Because we don't want to do this every time we have to solve these problems to go from here to here. Well, we can just divide whatever our power is here under our radicand by 2. So if we wanted to simplify the square root of x to the 8th, well, we know our power here is 2. We know to simplify this is going to be x to the 8 divided by 2, which is going to be x to the 4th. And this is our simplified answer. So let's use this property to simplify some expressions. So for number 1, we want the square root of x to the 10th. We know our power here is 2, so we know that simplifying this is going to be the same as just dividing that our power of 10 under the radicand by 2. So our answer here is going to be x to the 5th power. All right, so for number 2, we've got the square root of y to the 9th. But we notice that if we'd use the same property, if I just divided 9 by 2, we can't divide 9 by 2 and not get a decimal. So I don't want to do this. So I want to do something else. We know that we can break apart our y to the 9th into y to the 8th times y to the 1st. We know y to the 8th times y to the 1st is going to be y to the 9th. So I want to factor y to the 9th into this, and now take the square root of each of these. And I'm choosing y to the 8th because 8 is divisible by 2. So this expression here, the square root of y to the 8th, is going to be equal to y to the 4th. I'm dividing that 8 by 2. I can't do anything here, so I'm just going to keep this square root of y. So my answer here is going to be y to the 4th times the square root of y. Number 3, we've got the square root of x to the 6th times y to the 3rd. Look at my power of 2 here. Let's break these apart. So I'm going to take the square root of x to the 6th times the square root of y to the 3rd. For this expression here, since my power is a 6, I can divide 6 by 2, and this is going to give me x to the 3rd. Well, I've got a 3 here, though. I can't divide 3 by 2 and not get a decimal, so I'm going to break this apart into y to the 2nd. So I want the square root of y to the 2nd times the square root of y to the 1st. Now this square root of y to the 2nd, I can divide my exponent, 2 divided by 2, and that's going to give me y to the 1st. I can't do anything here, so I'm just going to leave that as the square root of y to the 1st. So let me just clean this up a little bit. So I'm going to get x to the 2nd, y times the square root of y. Now this is my answer for number 3. Number 4, let's factor this a little bit. So I'm going to take the square root of 12 times the square root of z to the 9th times the square root of y to the 11th. So 12 isn't a perfect square, but I know I can break up 12 into a value that is a perfect square. So I can break it up into the square root of 4 times the square root of 3 I have another video on factoring square roots. I'll attach that at the end of this video. Square root of z to the 9th, I can break that up into z to the 8th times square root of z to the 1st. And then y to the 11th, let's break that up into square root of y to the 10th times square root of y to the 1st. Now, everything that we can factor, or can take the square root of, let's do that. So our square root of 4, our square root of z to the 8th, and our square root of y to the 10th, we can take the square root of all of those. So square root of 4 is going to be 2. Square root of z to the 8th is going to give us z to the 4th. And our square root of y to the 10th is going to give us y to the 5th. Now, everything that we can't take the square root of is going to stay under our radical. So it's going to be our 3, our z, and our y. We're going to have 3, z, and y remaining under our radical. And this is our answer for number 4. All right, let's do one more example. For number 5, we've got 4x to the second y times the square root of 18 x to the 18th y to the 5th. So we've got everything outside the radical. So we're going to leave this outside the radical for now. I'm going to start by factoring everything under the radical. So I've got 4x squared y times the square root of 18 times square root of x to the 18th times the square root of y to the 5th. Let's start with our square root of 18. We know we can't take the square root of 18. 18 is not a perfect square, but I could factor this into square root of 9 times square root of 2. And I'm going to bring everything down along with this. So 4 times x squared times y times square root of 9 times square root of 2. Now my square root of x to the 18th, this value here, I can take the square root of because 18 here is divisible by 2. 18 divided by 2 is going to give me 9. So this is going to be times x to the 9th. And this value here, the square root of y to the 5th, I can break that up into square root of y to the 4th times square root of y. So I could take the square root of 9. I could take the square root of y to the 4th. So I'm going to rewrite this, pulling all of my values that are not under the radical out front. So 4 times x to the 2nd times y times x to the 9th times the square root of 9 is going to give me 3 times the square root of y to the 4th is going to give me y to the 2nd. Now my values that are going to stay under the radical are going to be the square root of 2. I can't take the square root of that. And the square root of y. I can't take the square root of that. So it's going to be 2y under the radical. Now let's simplify everything outside of our radical. Starting with 4 times 3, giving us 12. X to the 2nd times x to the 9th. And we're going to add our exponents. So it's going to give us x to the 11th. And then y to the 1st times y to the 2nd. That's going to give us y to the 3rd. And then times our square root of 2y. So this is going to be our answer for number 5. This video was on simplifying square roots. I hope this video helped you understand this concept a little bit more. If you like this video, leave a like, comment, and subscribe. And check out the link for the video that's coming up right now on finding the exact value of square roots. This is Nick from First Coast Math Clinic.